beginning stage for the data mining is actually starting from Walmart. It's all because the Walmart collect a lot of customer data and a lot of this kind of retail sales data. So at that time, the Walmart had some thinking. Now we collect so much data, and can we make use of this data to create some business value? So that's the beginning stage. The Walmart recruit a lot of statisticians as well as some computer science people and try to put together and get some data mining initial idea. So we know a lot of data has been collected in many places, like the department store and well, of course, the banker and the financial industry, as well as the network. And because I have collaboration, say for instance, I have collaboration with Daniel as well as the market, and we have been working on many this kind of network data as well. And the things getting easier for us is now the computer becomes much more powerful, and also the storage becomes much cheaper. I believe every people here will have a huge storage. Even for myself, I started collect data well, roughly from the beginning of my PhD career. So at that time, I started to collect data. So in my personal opinion, we collect two kinds of data. One type of data is for our personal development, and the second type of data is for organization development. It's more, one is for my personal agenda, one is for my organization agenda, when working for some organization. So the data collection becomes much easier, and now we all want to produce the value, not only the business value, also for the personal value from the data you collect, also the data collected by the organization. So also, since we are doing research in science, and now we have a lot of this kind of scientific data, say particularly for the past several years, the bioinformatics becomes extremely hot. So it's not like the wet lab stuff. Now people try to, using the experimental way to collect a huge amount of, say for instance, gene expression data, and they try to understand a lot of this kind of biological patterns. Try to do using computational way, try to analyze this kind of data, try to come up with some knowledge about the biologics. And typically, my understanding is data mining in this scientific domain can help in which sense? The first thing is now we are facing huge amount of data. If you have been working with them, say for instance, I did my summer intern at the Lawrence Berkeley National Lab, and actually I work, at that time I was working on a biological project. And once you're working on the real world project, you need to understand how big the data is. The data is really big. Say, it's not traditional way you can use some kind of, say, MATLAB or SAS, those kind of traditional statistical package. You can easily come up with some kind of pattern. It's very, very difficult. Some people use those kind of packaging. Either two directions. One direction, you don't get anything. The second direction is you take about several days or a week or even months running for some result. So that's why they actually they recruit me in a data mining conference to be there. So I write my own algorithm, try to identify some pattern. We call it we try to identify the protein functional module from this kind of gene expression data, as well as some the data collected from their wet lab experiment. So at that time, we use some computation method. Most likely is to generate some hypothesis. The way to understand data mining is it's not, say, we are using computational methodology, try to completely solve your scientific problem. It's more like we use this kind of computational methodology as the screen. It's more like we generate this kind of hypothesis for people, to guide people to doing some further experiments. The reason is people using the wet lab and many biological experiments produce a huge amount of data. Traditional way for people, biological people, they're doing this kind of scientific research is they manually observe the data. But in this stage, because we have a huge amount of data, it's impossible for people using this kind of observe way behavior try to identify this kind of hypothesis. So we must use some computational way. It's more like a screen. We try to identify some potential area which may have something to find and generate this kind of hypothesis to guide our future experiments as well as some understanding about this biological meaning. So this is from scientific point of view. And now we see the gap. This is pretty old graph, but we have two curves here. One curve is corresponding to the amount of data we have been collecting in every discipline in this world. And the blue line corresponding to the number of people who actually has expertise who can do this kind of large-scale data analysis, or we so-called data mining.
Is that number 0?
It's not zero, it's compared to this one because it's so flat. So the gap becomes huge, actually. It's even bigger. And that's why when I taught data mining class, and also I learned from data mining class I took from my advisor. And the demand for the data mining people, or this kind of large-scale data analysis people, becomes huge in the future. The reason is very simple. And you can think about it. One thing is, every company, no matter how small, they are collecting data. And eventually, they are going to make use of data, try to understand many things. You can say, for instance, right now, if we look at many these, we so-called this kind of smart car. Smart car is now every car, they have installed a lot of these sensors. They are going to collect those kind of sensors data and store in the computer in the car. Every car is a computer. And in the future, the car can talk to each other. And also, they collect the driver's behavior. Say, for instance, how many times you hit brake, how frequent you hit brake, how many times you just fill in the gas. And those kind of things will be recorded in the computer, in the car. So in the future, the car company is going to make use of all this data stored in the car, in the smart car, and try to understand your driver's behavior and try to understand the load situation in this area. So so basically, this just gives you a rough idea, and also for the cell phone. Every cell phone now they collect a lot of data in the cell phone storage. Because our storage is very cheap, it's affordable to collect all this data and store in those kind of smart devices. So in the future, almost every company, every industry, they're starting to collect huge amount of data. And those data will be accumulated like exponentially grows. But the number of people who actually has this kind of expertise can analyze this data is growing, is very slowly. So the gap will be huge. Another reason is about privacy. We are talking about outsourcing. In America, many manufacturers been outsourced to India, to China, and to many other countries. But there's one thing, it's difficult to outsource. Data analysis. Data analysis is usually very difficult to outsource. The reason is very simple. People don't want to give out data. If you don't want to give out data, it's not possible to do this kind of outsourcing stuff. And also, this position is very sensitive. Say, for instance, Intel, they set up their data mining lab. Why? They try to understand, because they have very sophisticated software engineer or hardware engineer, they design those kind of real asset design. They try to collect those kind of real asset design into the data. And they try to use data mining techniques, try to identify some patterns, say some patterns which can lead to successful design. Those kind of things they don't want to leak out. So they have to put those kind of data analysis in-house. In other words, they are not going to outsource this kind of stuff. They have to make sure those kind of knowledge will be well protected in-house. So this is another reason. This gap will become bigger. It's more like a DBA. Now we all, most likely we all understand. For a DBA, working for a company, usually DBA, you are not going to change DBA.
What's a DBA?
Database administrator. So you are not going to replace this position quite often because this person knows all your data. And think about the people who is doing analysis on the data you have. They understand more than you. I just give you one example because I taught EMBA class, and what I mentioned is about the information security issue, and he actually gave me a very good example. So basically, he has a DBA. He mentioned that this DBA, he didn't do much things in the job, but he has to pay him a lot of money. But this position is so important. He actually has to travel to Japan and disappeared for 3 days. And there's a very important contract in his company. Has to get his authorization to get the check agreement to sign the contract. But anyhow, he has found in Japan. These people cannot find him, but what they can do, they just find this DBA and change the permission. So basically, only him can have this permission to sign this contract, but somehow they change the permission in the system, let the other people to sign the contract. Otherwise, he come back, he's very extremely upset. He said, this is my company. I specify the rule. Now you change my rule. He said, I didn't even care about this contract can be done or not. I only care about my authority. If you can change this time, and in the future, I may lose this company. That means you can do something I do not even know to my company. So we just see nowadays data becomes extremely sensitive, and the data power, data control becomes extremely sensitive. So this is another way to look at the motivation, how these things will getting more important in the future. Regarding the scale of the data, I don't even mention about it. Now it's huge. If you're working with the AT&T and also you look at the finance industry, you can understand how big the data, and also the power for the Google. I don't even mention about this. The Google is getting more power in this society, in this world, because Google knows more information about everyone. He knows your behavior, maybe even better than yourself.
He knows what?
He knows your behavior, even better than yourself. Well, you use Google, you search, your interest, your hobby, everything, Google knows. If he wants to know you, he can know you. So this is, Google is getting huge power. But this is more like society concept about how those things goes. This just gives you an idea. We have more data to be analyzed, and we're short of this kind of expertise. So what we actually need for data mining, and based on the analysis at Berkeley, and typically right now we collect a lot of data, but only about 5%, even less than that, has been analyzed, has been used by the people. So the most data we simply waste. We don't use that, but still we collect in somewhere. We store it in somewhere. So we use data mining. It's not like traditional database research. Traditional database research is more like a query. So we're doing some queries, for instance, trying to find the salary, average salary for the faculty member or female or male faculty member. Those kinds of things are traditional database query. For data mining, we are more interested in sort of like this kind of intelligent question. Say, for instance, can we find old case of fraud, like this kind of financial fraud? Say, I give this example because recently I give a lot of lecture on the financial fraud detection. That's an excellent example. There's a most recent one. There's a person called Alan Stanford. Alan Stanford is another person actually called recently, and Madoff, is another person doing this kind of financial fraud. And Alan Stanford is another so-called banker. But he did nothing, just like those kind of pound schema. He collected money from the people. He didn't invest. He just collected new money to pay the interest as well as the money for the old people. So this we call the town scheme. So all this kind of fraud. The interesting story is that FBI actually chased this person, Alan Stamp, for more than 10 years. They has no clue what this guy doing. But there's a person, he knows a little bit about data analysis. He sit there for 2 hours. He tried to collect all the financial statement from this company, the company by Alan Stamp. And sit there for 2 hours doing some analysis on his financial statement. He made the conclusion, this guy is doing a lot of fraud things, monkey business. Because those things cannot be consistent, all the attributes, items cannot be consistent. So it's very easy to identify this guy has fraud behavior. He cannot produce so much profit. He cannot sustainable for his company. And many other examples is, do you want to find all the customers who would like to buy this kind of particular car? And also the question like, can you acquire new customer? And this customer group should be most profitable. So this kind of question is actually, we try to answer this question using the data mining techniques. Also, so many, this kind of so-called intelligent question. That's the difference between the traditional database research requirement. So for the data mining, and there are many definitions. This is one traditional definition. It's trying to identify the we so-called implicit or previous unload this kind of information. This information has to be useful, should be actionable. We can use this knowledge or use this information to guide our future behavior. Say for instance, for the Intel, they analyze so many real SI design. They try to identify some patterns. This pattern can be used to guide, to train the new people, new engineer who come in, try to design real SI. So this kind of knowledge has to be useful and can be used to guide for future activities. So these are typical process for data mining. First, we have to have some raw data. So we have to collect some data. And then we do some data pre-processing, like feature selection, dimension reduction, many things, like clean the missing data, those things. And then we apply some data mining tasks. For this part I'm going to introduce, basically we have 4 categories of data mining tasks I'm going to introduce, and some post-processing. The post-processing, and this may be more like control things. They have a feedback system. It's more like iterative process, trying to understand better about the whole thing in the data. So to make the concept more clear is give some idea what's not data mining. For instance, try to find a phone number from the phone directory, that's not data mining. But what's data mining is they try to understand some information. Say for instance, search engine, those things doing is they most likely they do data mining. They use one type of technique called clustering. As I'm going to introduce, they call document clustering, and we use a lot for the data mining. This is an example to show. We call this as widget data mining. Say
what did you just use? We call this
widget visualization. Visual data mining. Say for this one, we just visually show some statistics on the map. This is a US map. And the blue circle indicates the single man. The red circle indicates the single woman. And the circle size indicate what's the density population, how many they are here. So we can easily see the pattern, right? So these are West Coast, Silicon Valley. And this is Seattle. And here we can see this is New York area. So you can easily see the pattern, right? And you can get some interpretation. So you can see there are more single women, East Coast, more single men, West Coast. And all these are IT industry, right? Silicon Valley, Seattle, and these are several Austin, and several Texas. So these are this is 2007 from the National Geographic magazine. So this is one type of example to show this is one type of data mining task. And this can tell you many information, and a lot of information actually you can get from here. And now the question is, how can you make this kind of knowledge? You can do some business, or you can produce some business value, some custom value, and also maybe you change your personal agenda. Say, for instance, if you're doing IT things, and you are still single, you may want to find a job here. You can do IT for the finance industry, right? If you are single, that's a good choice. You can come to here. So you can change your personal agendas. So these kind of things you can identify. Well, I can give you many of these kind of examples. And this example can change not only for the business side, also change for the personal side. And you can change a lot of things for yourself. So
Excuse me, this is an example of projecting a data set onto a particular known function. So here you're mapping it to a particular location. You're going to talk about, I look at that as almost like a basis function. So you're going to talk about how to structure these data with respect to different bases or something like that?
For this tutorial, I'm going to introduce some basic data mining tasks, as I'm going to introduce next slide. It's coming. This just gives you some quick example to show how actually these things. So now we come to the data mining techniques. The data mining is an interdisciplinary area. So as I mentioned, about 20-year history for the data mining. And data mining is more like interdisciplinary area. You try to combine the knowledge and techniques from this is my understanding from 6 domains. Some techniques from statistics, of course, and some techniques from machine learning. Machine learning is more about learning. Some prediction part, tasks from machine learning, and some pattern recognition, and some database technique. Database technique most likely used to try to handle the large scale data. How can we make those kind of processing more efficient? And some optimization technique as well as some visualization technique. So this is more like interdisciplinary area to combine knowledge from 6 different disciplines. So there are many applications. I already mentioned some, and I don't go into this detail. I'm going to introduce some on the way. And this is some special one. And actually, this is fraud detection. Even for our network, I used to work on a project when I was a PhD student. I used to work for Army project. We were doing network intrusion detection. And right now, I'm working on the financial fraud detection. In terms of technique, it's more or less the same. Techniques is more or less the same. The only difference, as I'm going to introduce in one slide, for ourselves, for data mining people, typically we have to have 2 knowledge sets. One knowledge set is techniques. It's more like you understand what kind of data mining techniques, what kind of techniques you can use for data analysis. Another knowledge set is domain. The domain knowledge set. The domain knowledge set is very important for help you to formalize the features, attributes, and formalize the problem. This I'm going to introduce more later. And there are many other related to our case, like this kind of telecommunication phone call fraud. Now we look at, I briefly touch this slide. I'm going to introduce these slides more in the end of this presentation. This is my understanding. Data mining is like a career. Medical doctor. It's very like a medical doctor. After I introduce the later on slide, you keep this in mind. After I introduce more slides later on, you pretty much can understand why I put these slides. But you just keep in mind, as a data miner, it's more like a medical doctor in terms of career scheme. So now this is a general understanding about the categories for the data mining tasks. Data mining in general, we have 4 categories of techniques. The first category is the so-called clustering. Clustering is also we call as unsupervised learning. The idea for clustering is very easy to understand. You look at things which look similar, group them together. Say for instance, assume that this person, he never see apple, but they give them a bunch of apple. They based on the similarity can look at the shape, and you pretty much you can group them together. This we call the unsupervised. We assume that, say for instance, assume that a person, he doesn't know what's this. But if you give them several similar stuff, they can group them together. So this is more like unsupervised learning. They don't know what's this, but based on the similarity, they can group them together.
What's the metric for similarity? I'm just trying, I know I'm asking abstract questions, but what is the metric for similarity?
I'm going to in detail. This is just some general introduction. The similarity, we have many ways to define it. We can define based on some distance, and we are going to introduce that once I go into the slides. This is more like a general picture, a global picture. So this is one type of the unsupervised learning, this we call the clustering. And the second type of task for data mining is more like a prediction. Prediction, you can think about is more like a supervised learning. So you already have some learning examples. Say for instance, for the credit card fraud detection. For the credit card fraud detection, you already know some customer who actually who default. You know this is bad customer. You already get the label for some previous customer. So this thing, and also you know some customer which are good customers for the past 10 years. They pay their credit card regularly, and they never. So you know these are good customer, bad customer, good customer. So you get the training data. So based on the training data, you can build a learning model. Based on the learning model, you can predict new customer coming. Say for instance, when you apply for credit card online, say, I guess many of you apply for your credit card online. And in the end, you basically have three results. Either your credit card approved, or is denied, or pending. Some customer service has blocked. So this is more like based on the learning model. There's no human seed behind. It's just a learning model. Most like the decision tree type of things. It's a running background, and try to make this automatic prediction for your case. You just input your data. So your data is sort of like attributes, which can be used for prediction. So this is the second type of the work we call the supervised learning. It's called unsupervised learning. It's called supervised learning. This one we call association analysis. Association analysis is you have many events in this world. So basically, you try to identify certain events which has association or correlation to each other. Say for instance, two things happen. You may find that those things often appear together. But the correlation, we doesn't mean it's causality. Just say we have this observation. They happen frequently together. That's all. So this association analysis is we use to identify the correlations between different events, among different events. Anomaly detection is the last category. For this one, it's try to, this is also a type of unsupervised learning. So basically, we try to identify the things which are significantly different from the majority. If you look at standard deviation, it's more like it's more like outlier. We try to identify the outlier from the majority. For instance, in this case, majority here, we just identify these things. So anomaly detections we are going to introduce, they also have many applications like network intrusion detection, sort of things.
So are two of them support, for example, the supervised learning and two are unsupervised? Or things you just said?
Only this is supervised.
Only that's.
Oh, for the rest, it's not supervised. Supervised is we have training. We already have the learning example. Based on the learning example, we can build a learning model, then we can predict. That's what we call the supervised. So we first look at the clustering. Clustering is trying to find the groups and which are similar to each other. And basically, if you formalize to some optimization problem, is you try to minimize intra-class distance, and you try to maximize inter-class distance. Say for instance, if you formalize k-means clustering, you can formalize this way. As for the distance function, this is a big research problem. So it depends on how you define the attributes. we have many ways to define the distance, Euclidean distance, or use some information theoretical algebra. Someone use relative entropy to define the distance. So these things, it really depends on your context, your application context, and your data context. Say, for instance, if you have continuous data, and also you have high-dimensional data. I just give you some example. For the low-dimensional data, and if the data is continuous variable, you can use Euclidean distance, that's fine. But if this is a high-dimensional data, I mean high-dimensional means if you have more than 10K attributes. In this case, if you use Euclidean distance, it doesn't help.
Okay, hold on, right there. So the 10K attributes, that's kind of your basis set that defines the data set.
I just
Okay, I'd like to play with this a little bit.
Sure.
10K attributes. So these are your points are 10-dimensional points.
No,
Each one of your
10K,
base-
I mean dimension. I mean 10,000 dimensions.
Yeah, exactly. So, but you chose those dimensions, right? There could be another basis set in which to represent the data that makes things clearer. What you're trying to do is essentially find those basis functions. I may be speaking a different technical language. I know the communications theorists know exactly what I'm talking about. But
I'm not sure the question is asking about the clustering objective itself, or you're asking for more technical question, how we do feature selection.
in a statistical analysis, what I do is I look at a set of points and I do something called an algorithmic expansion, where I look and see for each, I look for independent dimensions.
Right.
And things cluster on those independent dimensions. It sounds like you're doing something, you're starting with some set of attributes that are your dimensions, and then it looks like you're trying to organize them.
But you can understand it this way. And for the things you just mentioned about, you look at some specific dimension. There's a category for lab research in this area is called subspace clustering.
Thank you.
So just like if you have 10,000,
Got it.
I only look at some subspace clustering.
I'm sorry to be a pain in the butt.
No, this is more.
Desperately interested.
Yeah, this is more general instruction, and that's an area, sub-area called subspace clustering.
All great professors are a pain in the butt, I know.
Right. So, by the way, I do have the PhD minor in statistics. I took a lot of class from statistics class. And so this is just some conceptual level introduction. Back to the point I just mentioned. So for the distance measure, it very depends on your data. So if you have more dimensional data, continuous variable, you can use Euclidean distance. But if you have categorical data or binary data, you may use some different distance, like Hamming distance or loss. And if you use have high dimensional data, then you have to be very careful. Say, for instance, like if you like example for high dimensional data is document data. For document data, is every document is a vector. Every word is more like the attributes. So this can be very extremely high dimension. For this high dimensional data, you cannot use Euclidean distance. Then you have to use cosine distance or some other cosine. Cosine is measure the angle to vector. You try to measure the angle, so it doesn't matter how many dimensions you have. So that's the distance definition itself is a lot of research. But keep in mind, it really depends on the data you have. So that's why data mining is not so trivial and easy to do. Because once I talk to some people in the company, they just say, I just want the data. I got a SAS package. I got SPSS Clementine package. People give me the data. I just want. They don't even consider about what kind of distance measure they are using. They don't even consider about what kind of data they have. And how about the missing value? And they don't do feature selection. And they produce something and they say this is data mining result. But this result may be just garbage in, garbage out. Means nothing. So we're going to talk more about this along the line. So here for the clustering, we can have many examples. One clustering application is we can try to reduce the size of the big data set. Say for instance, we can use k-means try to group this kind of climate data and try to make similar ones together based on some variables. And also for the finance application, this is one of my research I'm doing is I'm trying to, based on the stock market data, try to understand, try to find the stock for the several different companies, their stock they're going up together or going down together, and within certain time window. So this is sort of like their price movement is classed together. The price moves towards the same direction with some time lag. So this kind of information you can straightforward, you can make use for if you want to do stock trading. This kind of knowledge can help you to develop your trading machine. I'm not sure how many people heard about this concept called automatic stock trading or called trading machine. Trading machine is nothing, some rules. So basically, it's not the people sitting there to, people, of course, the trader were sitting there to watch the trading machine. But actually, the trading machine is doing a lot of trading automatically based on the rule. The rule is very simple. I used to look at some trading machine. It's just like, more like if condition. If condition A satisfy condition B satisfy condition C satisfy, we purchase certain stock at its price and something like this. It's more like if then means something. And so those kind of combination of the rules, they form the trading machine. So this is automatic trading. But making this kind of rules is produced by two ways. One way is by traders' knowledge, this experience. And the second way is by a lot of extensive data analysis, trying to understand the past stock market. And this understanding is changed. That means this data analysis is real time. They produce this kind of trading rule, real time trading. This new rules is fit into the trading machine right away. And some rules has as the time effect seasonality. This tool can only work, say for instance, in fall. It only works for this particular time. They have very complex philosophical way to divide these things. But the basic idea is you try to understand the market using the way doing data analysis. And this data analysis, large scale. Because it's very easy to understand every day how many transactions you have. This has to be large scale data analysis. So the clustering can help to summarize, to reduce the data size, and also to help you to understand the data, to generalize some patterns from the data. These some other applications. Say for instance, you can use the clustering technique to do the customer segmentation. And the customer segmentation is extremely helpful. Why is it extremely helpful? Because I'm from business school, and I can understand this much better now. Say for instance, if your manager just asks you, why are you doing marketing study or you're doing some customer relationship management, I just give you a task. You try to acquire new customer for me. How can you do that? Now I give you a question. Now you want to acquire new customer, and this customer can bring the most profit to a company. So the simple way is you can just using your current customer set, doing customer segmentation. That means doing clustering, and then you identify a group of your customer which are most profitable, and starting from this group. And they may have their own social link network, someone in LinkedIn, someone in Facebook. So if you go to their social link network, you identify all the people. Say for instance, if this customer, they have a lot of this kind of friends in the social link network, those friends will be your potential person to contact, try to acquire this new customer. So this can help you to do the market segmentation, customer segmentation, and to understand your customer. And the document clustering, this is more for the search engine. The search engine, the idea for search engine work is also very simple. I can concept level briefly introduce. Now we have so many documents on the internet. How can we quickly search? Google search is so fast. There's one key technique they use is doing document clustering. They group similar documents together. So in this way, and then they can, based on the choice, they do some index. So the index is dynamic build every night. They build this dynamic change of index. So every time your keyword comes, they're going to hit index. And this index is going to link to the centroid of a certain cluster of documents. So when we pull out that one to show to you. So this idea. This document clustering is a key base technique used in the search engine. Clustering is unsupervised. That means it's extremely complex notion. Because it's unsupervised learning, and that means the notion of a cluster can be very ambiguous. Say, for instance, the same amount of data, the same data, exact same data. Some people can think it's 6 clusters, some people can think it's 2 clusters, some people can think it's 4 clusters. So that's why this kind of clustering research has been there for so many years. Statisticians actually investigate this problem for many, many years. Now for the data mining people, the new research data mining people are doing is along several directions. One is scale, large scale. Say for instance, can we make the traditional clustering algorithm is more efficient running? And also large scale means how can we handle large data and also large dimension? And how can we do this kind of subspace unsupervised learning and also semi-supervised learning? Although some things along this line. Because this is unsupervised learning, that means that this is a very complex problem. In other words, there's a lot of opportunity. People can play from different angles for this research. The types of clustering is typically we have 2 types of. One is hierarchical based, another one is partitional based. Partitional based is very simple. You just partition the space. Say for instance, this is your data. If you look at 2 dimension case, you just partition space, somehow you separate this cluster. So this is we call the partition based clustering. And another type is we call the hierarchical clustering. So we organize the objects to form this kind of text forming type of things. So this hierarchical type of clustering can better understand, can be easily to be interpreted, easy to understand. So this is the hierarchical clustering.
Can you maybe tell us or explain how one actually differentiates between these 2 cases? You've got the same data, all right, but 2 different graphs,
Right.
Right. Trees. So what is it that actually differentiates these 2 cases from each other? There's got to be some metric or some rule that you define that leads to type A versus B.
Right.
Can you maybe give us something a little more
Okay, I give more.
mathy,
Okay.
so that I get a good diet? Okay.
Okay. Say for instance, if we want to do hierarchical clustering, typically we have 2 ways. You can look at it from this graph. One way is you can do top down. Another way is doing bottom up. Let me introduce one way to doing bottom up. Bottom up means we merge objects. So there are 3 ways to merge the objects. One way is based on the mean. Mean, that means we first need to define distance. Distance measure between every 2 objects. And once you have the distance measure, then you have the metric to merge, to decide the merge. There are 3 techniques to use. One is the mean. Mean means 2 objects, we merge the most close 2 objects. The first step. So these are mean objects. The next step is within this cluster and the rest objects, you find the second, the minimum one. So these are graded choice. Every time you merge the minimum distance and you expand from the cluster. So this is one way. The second way, we use the maximum. And the third way is the group average. So this just gives you a little bit idea. Once you have the distance measure, you have 3 techniques: mean, max, group average. Group average idea is very simple. Say for instance, if you have a lot of objects and 3 objects already grouped in this cluster, and there are 6 objects already grouped in this cluster, and maybe there are some other cluster one. So you compute the group average. Group average means you compute the distance from these 3 objects to these 6 objects. So that means 3 times 6 will be 18. Then you divide by 18, so you get average distance for these 2 clusters. And then you compute distance from this 3 to other clusters. and eventually you find the minimum one to merge. Say for these two classes, based on the group average, they are minimal to other clusters, so you merge these two first. So this is the rough idea. So you can merge these clusters. Very simple idea. I didn't go into detail because we only have 1 hour. Yeah. If we go in detail, we have to take 3 hours at least. So this is the rough idea how can we do hierarchical clustering. And in practice, let me put it this way. In practice, there are some advantage and disadvantage. For the partition-based clustering, people use mostly k-means. K-means use a lot in reality. For partition-based clustering, the benefit is, for this one, is you can easily visualize C, and you can easily to integrate. And this is the good thing. The bad thing is, for this one, is a great choice. They don't have this kind of global objective function, not like this partition-based approach. Partition-based approach, they have a global objective function. They try to minimize distance within the cluster and also maximize the distance between the cluster. So that means they can get a so-called global objective function. Works, but for this one, they only have this rigid choice. That's the drawback for hierarchical clustering. Hierarchical clustering does a key drawback. Once you make a mistake, you cannot go back. So that means you have to design this point. Once you determine, then that's done. You cannot make a change. Cannot go back. But for partition-based clustering, it's more like iterative. You can change in between before you converge. There are some other distinctions between the sets of clusters. And for just now, we just introduce, we make a clear partition. But sometimes people make some fuzzy case. Fuzzy case means this object, it gives certain probability. It just says 30% probability this object belongs to class A, and 70% probability belongs to class B. So this we call the fuzzy. Sometimes because many objects along the board, people use this kind of fuzzy things to do that. And also, sometimes people don't want to cluster all the objects. They try to identify all the outlier objects and the noise objects. They first remove those kind of noise object, outlier objects. Then they do in clustering. Because noise and outliers can have a lot of impact, negative impact on your clustering algorithm. So if you first identify this outlier or noise using some other technique, then remove those kind of outlier and noise objects, your clustering result can lead to bad performance. So sometimes you're doing only partial clustering, that means you don't use all the objects, you remove some first. And there are some other things like exclusive, non-inclusive, and some heterogeneous and homogeneous. So these are many variations in this kind. So these are more research issues. For the clustering research, for the people consider about, is say for instance, one issue is how can you define the distance? The definition for the distance is affected by many issues, like the type of data, and also attribute type, and also dimensionality, and the type of distribution more likely for the density-based approach. For these things affect how you define this kind of distance metric. And also the data, if the data is sparse, or data is dense, or data has certain different type of distribution, then the choice of your clustering algorithm can be quite different. Say for instance, if your data is very skewed we mean, say for instance, assume that you know the class table, like custom true analysis. For the person who is going to go to your computer, it's not a large percentage. And for the, let's say for instance, network outlier detection, this is more easy to understand. Not many network traffic are actually flawed, only very small portion. So if you look at the distribution, it's very skewed. And now if you look at the medical case, the patient who has cancer actually is not a huge percentage. The most people are normal patients. They don't have cancer, only very small portion. So based on the distribution, the choice of your technique can be also very different. So every time if you're doing data mining, now assume that you have a clustering task in mind for your application. Then you first need to understand what kind of attributes you have, what kind of data you have, what's the underlying distribution for your data, and whether your data is sparse or not. All these things you have to keep in mind before you select one specific technique to use to do clustering. For clustering alone, you have a lot of choice for the clustering. And even you decide, if say for instance you decide to use hierarchical clustering, you decide to use k-means, still there are many things you have to do before you can really use k-means. Say what's the distance measure for your k-means, and do you want to do some data pre-processing? How many attributes are you going to use? Are you going to use all the attributes or not? So there are many things you have to decide before you can really do something. So this is about the clustering. Next, we look at association analysis. Association is, and this problem actually is quite computational intensive. This is more like a combinatorial problem. So basically, what this is going to find is find something like if you give a bunch of objects, you try to identify the group of objects which are strongly related to each other. You can put into certain context. Say, for instance, we put into the Amazon.com, this kind of context. Amazon.com, they make a recommendation. Those kind of recommendation is based on their findings about this so-called association pattern. What they find is, say, for instance, based on the previous customer purchase behavior, and these two books, say, for instance, these two books are frequently purchased by the customer. So the customer buy book A also will buy book B. So this is more like statistical summaries. They frequently purchase together. It's just based on observation. So this we call the association pattern. So this we define as association. And also some people in the statistical domain, people doing association analysis and association measurement, and some people call it as correlation finding, correlation computing. But in data mining area, this application, in data mining area, the most challenge is the computation. You can think this way. This case, we only have 5 objects. If you want to identify groups of objects which are strongly related to each other, what's your potential candidate? You have to search. The potential candidate is combinatorial groups. If we look at all the size 2, size 3, or size 4 cases, so this problem is mostly computational intensive. This is only 5 objects. You want to find all the group of objects. That will be 2 to 5. That's potential, roughly, this level computation.
Yeah, so what you're building is a conditional probability map.
Right. So I just mentioned about computation. So potential candidate is a lot.
No, I'm just saying that building conditional probability maps is computational intensive.
Right, of course. I just want to highlight this problem itself is computationally extremely intensive. This is combinatorial closed problem. So this is the most research challenge people are doing. So people try to reduce this kind of computation. So that's in this area most research doing. The application in this area, say for instance, you can find many applications in this area. Say for instance, for the market basket analysis, people try to optimize your share. You put in certain products together. Because based on the past behavior, you identify the customer frequently purchase these things together. So you try to buy these 2 items together. And also in telecommunication alarm domain, you can try to identify, understand what kind of alarm, what kind of fraud, what kind of the failures can happen in the system. And for the medical domain, people use this technique to try to identify the different symptoms and link to certain disease. And say, for instance, now in the pharmaceutical company, they use computational way, try to find those kind of drug-drug interaction. Based on the component of every drug, they try to identify this kind of drug-drug interaction. And right now I'm using this technique for the financial technical indicator. Because in financial domain, they have a lot of technical indicators. Technical indicator can indicate this stock will go up or go down, and we have a lot of these technical indicators. I try to find a combination of technical indicators which can make the prediction more powerful. And I'll try to understand this, the behavior of this group of technical indicators. So this is the second category. For this category, the most research challenge, I guess you are not so interested, is computation. But you have to keep in mind, if you want to use any technique for the correlation computing or this kind of association analysis, you expect the running time will take a lot of time for running time. So in statistics domain, people typically call this correlation computing. The computing means we have to deal with a lot of data. Even we're dealing with 1,000, think about the computation for 1,000, you try to identify all the subsets, that will be to the 1,000. That's a huge computation, combinatorial cluster. So for this area, from statistics domain, people call it as statistical computing or correlation computing in general. So this is the example we can frequently see on the Amazon or some other company. They try to identify these kind of things. This is just based on the frequent purchase behavior. They frequently buy these things together. Now, we have already introduced two categories. One is clustering and one is association. The next one, we are going to introduce the prediction. This learning model, I guess you may be very familiar with this concept. For this one, we call the supervised learning. Supervised learning means you already have the training data. Say, for instance, in this case, assume that this is a toy example. This toy example assume that we already know the customer whose credit score is high and the credit score is low. So we already get a bunch of knowledge about the current existing customer. So based on the existing customer and some other information, like what kind of education is a PhD, master, or bachelor, or what's the birthday, and how old is this guy, and whether this guy is married or not, has kids or not, or where this guy lives, and what kind of company or industry he's working with. So based on these things, we can build this kind of thing we call the decision tree. Decision tree is very simple idea. Every node is simply an attribute. Based on this attribute, we can decide this instance should go to which direction. So this we call a decision-based model. And for the real credit card fraud detection or real credit card proof, they actually just have a learning model is running behind. When you apply your credit card online, this kind of learning model is continuous running. So once you input all the data, quickly you can get the result. It just say based on your attributes, you just fall into certain categories. Say for instance, if you fall in this category, that means your credit card approved. If you fall in this category, it means no. But there are additional categories pending. You have to, some customer service people has to contact you. If based on the information you provide, this machine cannot make a decision, then human can get involved. So these are typical examples for the learning part. You have the training data, and based on the training data, you are going to build your learning model. And once you build your learning model, you are going to use the test data. The test data is, say for instance, if you apply credit card online, you become the test case. You input all the information, then you get a prediction label for your case. So this for the prediction. For the example of classification example, we can have many classification examples. Like you can predict the cancer is benign, this tumor cell is benign or malignant, and also many other things like fraud. And also I can give some example for the. So fraud detection is one example, and also customer churn analysis is another example. Customer churn analysis is you try to predict whether a customer is likely to be lost to a company. So say for instance, you are going to change your company. Say I'm going to change myself. Actually, I'm going to change myself from Sprint to some other company. That means I'm going to be a customer tuned to other company. And I guess you may be more familiar with this kind of systems. As I mentioned, the data now is collected everywhere. For the machine, for every machine, not even like the big machine like this, every small machine, they also collect all those kind of logs. And from all these logs you collect, you can try to use that to predict some failure events as well. So you can formalize a problem from the event log. You can do prediction. You and I have worked along this line. We try to use the system log. We try to predict the failure events. So this all like you can formalize a problem in this area. And also some other things like web usage mining, the same. You can try to formalize the problem as the learning problem. Say for instance, you can formalize a tool for the network intrusion detection and also some other web usage learning understanding things. Even for the sensor network. For the sensor network is now people try to do this kind of learning in the sensor network. So basically they try to identify some intrusions using this kind of sensor network learning. So this is another problem settings. We can actually formalize a problem to a learning problem in the sensor network. We try to identify some sensors moving and as well as some intrusion in the sensor network. So in terms of the techniques, classification techniques, we have a lot, very a lot. Say we can have decision tree, we can have rule-based classifier. Say for the trading machine, it's more like a rule-based classifier. If then those kind of based on certain condition make prediction. And also analysis label, neural network, SVM, and I guess you hear along this line, like SVM, neural network, Bayesian network, and those kind of things are some big category for the technique. For each category, you have a very small subcategory. Say for instance, for the support vector machine, you can use different kernel and many other things along this line.
And I think compression sensing is an element of the last category support vector machines. Because it's also used basis in sensor network to do compression sensing.
Say that again, what's the question?
For compression sensing.
Okay.
Do you think it belongs to the last category?
You mean belongs to support vector machine? Support vector machine is technically trying to find a hyperplane. It's a try in the space. They try to identify a hyperplane. This hyperplane can partition, can separate two group of class.
So each hyperplane is equivalent to a basis to extend the entire space, right?
Well, it depends on how you understand this, and it depends on how you define this. For the traditional definition for the support vector machines, people try to identify this hyperplane. This hyperplane will separate two classes. But later on, people develop the concept called traditional support vector machines for binary class. That means for two classes. You try to find the hyperplane to separate two classes. But later on, people extend this concept, try to find several different hyperplane for the multi-class. That means we have multi-different class. But the basic idea is the same. They can say, for instance, if you want to build many hyperplane, you can first think it's only two class. You find one hyperplane, and with this one, you find another hyperplane. So this is more like recursive partition space. So this is traditional we mean by support vector machine. And actually, for each category, if we are going to introduce at least one class, one lecture class, to introduce every individual one. And you can take my data mining class. Say for instance, Ben took my data mining class in last semester. You you know better, right? But
We pretend we don't.
yeah, I guess you.
You're guessing ain't been for.
Yeah.
Right. So we took my data mining class last semester, and we are going to introduce all these things in the class. For every specific technique, we are going to introduce many specific techniques for each subcategory. And in sample, it's the idea you try to combine the people's opinion together. This is based on some statistical theory. If every predictor has the prediction accuracy about 50%, if we combine them together, you definitely get an ensemble learning model which has prediction accuracy can be improved. So, but the basic assumption is every predictor has to have the prediction accuracy about 50%. So I don't need to introduce example of this decision tree. You can easily understand. So it's based on attribute. You just go to two directions. For all these techniques, keep in mind there's one thing in common is distance. How do you define the distance? In many scenarios, many techniques, they have to define the distance. For clustering, you have to define distance. For association, you have to define the distance. For outlier detection, you have to define distance. Even for this kind of learning, you also need to define the distance of matrix. Which side you should go, which side is you are more senior. So there are some fundamental things are in common. So these are some learning tasks. Now we look at the last category. The last category we introduced we so-called deviation of anomaly detection. For this one in statistical, they call it as the outlier detection. For outlier detection, it's more like you try to. Okay, I'm a little bit.
That's fine.
For outlier detection, it's try to identify the things which are significantly from the majority. So for anomaly detection is there are many challenges. The first is this is unsupervised. And also you are trying to identify something so real. That means it's not very open. For the pattern, we all know if we are doing a lot of data analysis or in the human life. For the things which happen frequently, you know it's very easy to find. In the crime, it's the same. Say for instance, a person committed a crime many times, that's easily to be caught. Most difficult to identify the criminal. He only commit once, and there's no any kind of interest. Just if he go to on the street randomly kill one person, he never do that again. Never do that again. Those kind of things very difficult to identify. Just like the same for the anomaly outlier. If this is outlier, it's anomaly, it's not frequent. That means it's very difficult to be identified. So in terms of technical people use is they typically try to profile what's the normal behavior in this set. Once we quantify this is our normal behavior, once we understand this is our normal behavior, then you try to make see if a person's behavior is not falling the category of normal behavior, then we call it this. So that's typical way for doing that. We have a statistical way to do that, distance-based approach, and some model-based approach. This graph-based approach, this is typically for the two-dimensional case, people are using, like this is once you visualize, you know it's outlier, because it didn't follow the trend with the majority. And the statistical way is you try to identify something like this, far away from the distribution. So for this technique, people use a lot for the network intrusion detection. Intrusion detection is you try to profile what's the normal access pattern. Once you profile what's the normal access pattern for any access pattern which don't follow this category, you call it as anomaly. Anomaly doesn't mean always mean something bad. It just means which is different from the majority. You have to look at it in detail, see whether this is real intrusion or not. So these some data mining technique people use some formats as a learning problem. That means we have the signature. Learning problem means we already know this type of behavior is an intrusion, like this kind of words. You already get a signature for certain kind of values of words. So this is one type we form as a learning problem. Another type we call it as anomaly detection. That means unsupervised. We don't have this. We haven't seen this pattern before, but we just know this pattern is different from the majority, from the profile we already got. So we call it a stop. So that pretty much I introduced the 4 categories of the techniques: clustering, association, classification, and anomaly detection. But all this KDD process, it just follow the same process. Most likely, it's just this process. It's very important. First, we should understand what kind of data we have. Once we understand the data, then pretty much we need to understand what kind of real task we have in mind. Are we going to do clustering? Are we going to do learning? Are we going to find some anomaly? Are we going to simply do this kind of try to identify the correlation among different events? So all these things are linked together. Once we know the task in mind, then we can do analysis like clean up data, try to do feature selection, try to do dimension reduction. If we have high dimension, we have to do dimension reduction. And we may not use all attributes because some, say for instance, if we're doing learning, if we're doing classification, not every attribute will contribute to your learning result. So only some of them can contribute to your learning result because some attributes they have duplicate effect and they can replace for each other. We only find the best subset of features which can be used for your task. So this involves something like a feature selection or feature extraction or even some feature reformation. You have to change it for your features. And they follow this procedure for the knowledge discovery. These are some challenges for the data mining. The most difficult part is scalability. If you really learn the real world data, you can understand. Say, for instance, when I was a PhD student, I was so sick before the computer. I running some algorithm for several days. I couldn't get any result. Even I put a lot of debugging information, they report some intermediate result for me. Otherwise, I have no clue what's happening in the machine. So, and sometimes I wrote something wrong, maybe, and I have to restart for the program. So scalability is the most difficult challenge for data mining people. And also, it's quite often dimensionality. Now, in the real world data, you can easily get a lot of attributes. So in this case, the large dimension and the high dimension usually cause a lot of trouble for your data analysis. So this means you either do dimension reduction or you do feature selection, or you extract some other features. And there are some other things like privacy consent. These things makes us very difficult to get real world data. It's not like before. Nowadays, companies, they don't give out data. And they have a good example for this. I'm not sure you heard about the story about AOL scandal. American Online, they have a scandal. AOL, they used to have a data mining research center. And they have a contract with Google. So basically, Google offered them Google search engine. So basically, AOL used Google search engine in their system. And that's one researcher. He actually wrote 2 papers, and they used some query logs. That means user query keyword search query logs, and he published those data on the web. He's doing some anonymization, those type of things. But still, many data mining research use those data, identifies very interesting stuff. Say, for instance, one data mining researcher identified a senator in some state. He actually looked at some website. It's not a problem for the people or for his position. So and then publishing some newspaper. So in the end, it's very bad result. And this researcher was laid off, and the manager was laid off. eventually the center was closed.
That's a great result for data mining. It means, I mean, think about it. They correlated this stuff and extracted individually. That's pretty cool.
Right.
As long as it's not me.
So after that, the people are very cautious people because they cause a huge this kind of lawsuit, and many people try to sue their company, and many this kind of sensitive information come out. So after that, it's very difficult to get any real world data from the company. So that's one of the big challenge. You cannot get data. If you cannot get real world data, how can you come up this kind of real world interesting research? So this is another dimension you can have. Now, starting from this slide, it's more like my personal understanding about the data mining. For data mining, typically, if you want to do a good job, we typically have two knowledge sets. One knowledge set is we call the technical knowledge set. And the nice thing for this field is we use a lot of traditional statistic technique, and we use a lot of traditional optimization technique. And this technique is more or less some math. Those things is not going to change very fast. So in other words, with the increase of our age, once we're getting old, pretty much if you're working hard, this knowledge set will increase for sure. And the second knowledge set is for your domain knowledge. The domain knowledge is more like, say for instance, now I'm working on the financial fraud detection or with financial data analysis. This set is also the domain knowledge, I suppose, will be grow when I grow up. So adding together will be your personal value on the market. So your value on the market is decided by these two sets. Remember, this set can be shrink. The same carefully. As you're getting old, this set may be shrink. If you're learning something that may be outdated for a while, think carefully. This can be shrink, and also this can also be shrink. So you try to learn something very careful, make sure these two sets grow, expand. So then your market value will be grow. And this is one of my understanding, and these are my second understanding about data mining. Data mining is most likely like a career. We call the medical doctor. Why I say these two areas so similar? For the medical doctor, you have to understand all the symptoms. And for every disease, they have certain symptoms. And so some new disease come out. Well, not so many new disease, most likely old disease. And you have to remember a lot of things. For data mining, the same. For data from different domains, they have some data characteristics. Say, for instance, some high dimension, some sparse, some dense. Some data has this kind of distribution. And some data, they have categorical data, binary data, continuous data. You have to understand all these data. They have different characteristics. And for different, and also you have to understand the different techniques. Some techniques only works for this type of data. They may not for other types of data. The data change a little bit, your technique has to change. Otherwise, you screw up everything. And the same for the medical doctor. Medical doctor have to understand the drug, the effect of drug, and has to understand all this kind of medical device. In which case, I have to use what kind of drug. In which case, I should use what kind of medical device. So these two careers.
I think the American economy appears in the future will always
Well, I believe we are going to spend a lot of money on data as well.
Yeah, I agree.
I believe so. This is one more understanding I have. Our whole life is a data mining. Why I say this way? When you are young, when you are very young, so a person can be very successful. Pretty much depends on these three knowledge set. Well, of course, it depends on your mind. This is your brain. If you are smart or not, is here. So basically, when you are young, you born in a rich family, and your family, say for instance, your parents are well educated. So that means you have excellent family knowledge set. Even this part, when you are young, is small. Doesn't matter. Because this part is very strong. And the knowledge around you will be very strong. And so most likely you are going to make the right decision when even you are very young. But if you are poor, that means you have to be extremely smart here. Because you only have limited knowledge here, limited knowledge here, limited knowledge here. You cannot see the complete picture of the world. You only see very, very tiny and independent, isolated part. But if you are smart enough or you are lucky enough, you can pretty much make some right decision. And if you are smart enough, and this set can be grow up quickly. Once this set, your knowledge set is grow up enough, it doesn't matter. You are going to build, it doesn't matter this part. You are going to build this part anyway. Then you can also be very successful. So that's why I say our whole life is a data mining process. We study, accumulate knowledge, accumulate data for our personal data, for our personal development. And eventually, well, of course, you have to train your mind. So in my opinion, in this world, if you want to be very successful, you have to have two skills. One skill is quick learning. You have to be a quick learner because too many things come out so fast. You have to be quick learner. And also, you have to be a quick problem solver. That means you have to know. There are so many information. You have to quickly pinpoint out the problem, identify the problem, and solve the problem. So if you have these two skills, you can be very successful. My personal understanding. Okay, so this is about some commercial package. These are for free for education purpose, and these are some very successful commercial package. I use the Clementine a lot, and also SAS.
So Clementine, you requires licensing, you have to buy and so on.
And
That's free, right?
we have university license. Yes.
Here.
I'm not sure. At this business school, we have these two. We have both. And these are some book. Oh, this is textbook. Textbook I can spend some time. If you are more interested in some basic stuff, these are basic textbook. If you are interested in more theoretical stuff, well, this one. This one is by Stanford statistician from Stanford University Statistics. Kipshioni. It's Robert Kipshioni and also the Jerome Friedman. They're from also Hastings. They're from statistics department. Stanford University. Okay, that's it. Thank you.
Thank you.